Hi, doggies. What should we do video about today? Multimeters? Okay, I'll get one out. Hey, what's up, guys? Today we're going to take a break from building the Elenco multimeter. And instead, we're going to focus our efforts on what we got here on the table, which is from Zotek. Doesn't have a model number or anything on here, so let's see what we got in the bag. This is the ZTY. Stop testing voltage and current mode. Yeah, that's a bad idea. Don't do that. No batteries in it, but I didn't expect that since they sent me batteries. So this is a 9,999 count auto ranging digital multimeter. Let's see what it's true RMS. So we've got capacitance. We've got delta to relative, set things out. Diode continuity, duty cycle, secondary measurements, we'll see that. Frequency, temperature. Oh, it's got a bar graph, those are nice. Resistance, current, voltage. Product measures both sinusoidal and non-sinusoidal AC waveforms accurately. That's true RMS, yep. Okay. I'm just going through this real quick. This is a nicely done manual. It is better translated than most of the other manuals we come through. Oh, it's got NCV. Does it really have NCV? We'll find out. V.F.C. Voltage. Yeah, I don't know. Maintenance specs. Oh, here we go. Specs 9,999 counts. It is auto manual, made out of ABS TPE. Update 3 times a second. True RMS. Data hold. Backlight. Low battery. Auto power off. Here you can see some sizes and whatnot. Here are our electrical specifications, which you can pause and peruse at your leisure. All right, so it comes with, this is a real nice chewy, like I can get my nail in there, thick cover. Is there a screen cover on here? Yep. It's larger than the older Zotek. So let me go get one of those. Hold on. And let's go to the multimeter display area. And that's the one I'm thinking of. Yep. Okay. So you can see they're based off of this generation. This is the ZT102. And it is considerably larger. All right. This lists on AliExpress for about $39, depending on where you are shipping and whatnot. Will be a different prospect for you. Let's change things up today. Let us instead take it apart first, and then we'll check out its function, assuming I don't break it. All right. Unhand your keyboards. Yes, I am copying off of Dave just a little bit, just for fun. I didn't say his catchphrase. No need to lash out with venomous epithets. You can tell I've been watching Deadwood again, lashing out venomous epithets. Swearingen could certainly turn a phrase, couldn't he? I always liked that show. I've watched it probably 3 times. Mostly for the dialogue, to be honest. Alright, what do we get? I need to remove this too. Look at this to me. What do we get? What do we get? Like, is it a prize? I like prizes. 3 AAAs. Brass insert. Am I missing a screw somewhere? Well, looks like I'll have to get a spudger. Spudger in hand, we press on. This is not like an outer. There we go. Okay. Alright, so we look here at the circuit board. We got spring-loaded battery contacts. Those are nice. We've got 2 fuses, 200 milliamp, 250 volt, 10 amp, 250 volt. We've got our current shunt. Interesting there. Now, there's a, how well you can see that. Maybe I can help you see it better. Yeah, you can see. Looks to be a bite out of there, which could very well have been done to trim it out. We got a little melt resistor tree going on here. We got a PTC here. Bet you that's a voltage reference. Let's see if we can make it out. ICL 8069. I was right. The ICL 8069 is a 1.2 volt temperature controlled voltage reference from Maxim. Now, what are these little guys? Are they transistors or voltage regulators? Y1. Yep, those are transistors, Y1s, which are S8050s. NPNs, yeah. Think there for a second. What's this chippy chip here we got? It is extremely difficult to read this. Does that say T24 CO2? I have no idea. If you feel like looking it up, you can. That's going to be our main chip there. With good enough soldering. We've got, this should be our NCV, but I don't know if it's populated or not. Well, we'll certainly find out. There is a 4 megahertz chip, or 4 megahertz crystal. Yeah, let's put it back together. See what we get, right? Alright, now, interestingly, they only sent us 2 batteries and it takes 3. Long life. Guess they couldn't afford the G in long. That's okay. Should definitely send the right number of batteries, so that could be somewhat off-putting to an individual. Not me. I don't care, I got batteries. And it's not like I'm counting on the absolute bottom of the barrel batteries that everybody gives you. I look at those batteries as good enough to turn the device on and make sure everything functions. Beyond that, those batteries mean nothing to me. Yeah, it does have NCV. Okay. That was just the first thing I wanted to test. Alright, like we said at the beginning, there's a manual included, K-type thermocouple, and some leads. As is usual, we will be testing this meter with our leads, which are the gold-plated ProbeMaster leads. I'm not saying these leads are better, I'm simply saying that when we started this channel 6 years ago, we determined when testing multimeters, we would always use the same leads. That way, there's a nice tight fit there too. That way, no matter what meter we go through, we are using the same leads, so we have the same resistance, and we're only testing the meter. So this is the continuity. The beeper is loud. The bar graph disappears. I like it. I'm not sure why it's showing me voltage instead of resistance though. Unless that's that V.F.C thing they were talking about. Interesting. Alright, let's get us set up for our tests. To do that, we're going to start out with the AD584 voltage standard. And somebody asked me in a previous video, well, how do you know it's accurate? Well, honestly, I really don't. But you got to believe somebody. You got to start somewhere. This is as good a place as any. We'll fire that guy up, put it in its low end, and we'll let it sit for a few minutes. And while we do that, let's take a look at some LEDs, diodes. LEDs are diodes, obviously, and capacitors, and see how it does. So, let us put this resistance, diode. All right, we'll do diodes then. Here's a big rectifying diode, and it's showing us 0.575. Here's a smaller one. This is a Schottky. No, this is a silicone junction too. 613. All right, here we go. LEDs. Red, and it's showing us our voltage and lighting it. Yellow, same. Green. It is lighting the green. It's very dim. I don't know how well you can see that. Blue. Kind of doubt it's going to light this one. Oh, wow. No, it does very well. So it's definitely using 3 volts or 3.2 volts for the diode check. All right. Where do I go? Okay, there's capacitor. Auto. Alright, going to have to look it up in the manual. That's 1 point off for making me look something up in a manual. Short press, switch among functions. It seems to me it is not switching in there. Sorry about that. Current. Capacitance. Connect the blast lead to the COM terminal. Red lead to this one. Turn it over to this. Press select to the capacitance test. Like, there's the instructions. Okay. There's where we're hooked up. There's where the knob is turned. And now it says I should be able to press select to the capacitance mode. Let's do it. There we go. That took a bit. All right, let's see what this little guy says. That's a 100 nano. It's coming out 105.8. Good. And this one, is that really 50 microfarad? Dagnabbit. No, that's 10. I think I had a 50. Let's try that again. I know the screen is hard to see there. Oh. Am I losing my mind? Oh, it's 47. Okay. Whew. I thought I was going to have to put the kibosh on this thing. Instead, it's just my poor eyes. All right, next one. That's 3.3. That's good. Let's just check the big one, which is 10K. That's a read. 1,000. Close enough. Good. I have angled that better for you. All right, so now we're in DC voltage. Bring in our DC voltage tester. And we're starting out at 2.5. 2.504. Next. This should be 5. Yep. 7.5. 10. Good. Let's have a look at some AC voltage. We generally go between 123.5, 124.5 around here. Oh, 125.5. We're a little high. And you can see our frequency there right at 60 hertz. Very nice. All right, we have a square wave generator, and we're definitely going to try that. 50 hertz, 100 hertz, 2, 3. 5 kilohertz. Let's hook it up to the oscilloscope. And we'll see what we get. I'm going to press the auto set on the scope while we bring the there we go. Looks good. Let's see here. 5.002 megahertz. I'd say she's doing pretty good. Hang on here, let me adjust this. All right, we're going to go down to 50 hertz. Here's 100. Adjust our just read a frequency right there. There's 100 hertz, 200, 300, 400, 500, 6, 7, 8, 9,000. Friends, that is a nice square wave generator. I enjoy that a lot. All right, let's have a look at temperature. There it is. And yes, it does have an internal temperature sensor because it is just about 70 some degrees in here. It's actually about 74, but I'm not going to get off on that too much. Yeah. For a $40 meter, you keep this thing, you know, household voltage or less, you know, 120 or so less. I wouldn't do this on 240. And I think you'll have yourself a nice little hobby meter. I want to thank Zotek for sending that out. I want to thank you for watching. That's it. I'm out. Peace.